Hey class, today we're going to be taking notes on absolute value equations, and this is just going to be day one of the notes. We're going to be on page 19, so if you can follow along and write down the examples and write down the problems and the steps as I do in the video. I will ask you a couple questions along the way. You can always pause the video and rewind if I'm moving too fast, okay? All right, so we're going to talk about absolute value equations. But first, we're going to do a little vocab, right? We're going to talk about absolute value, right? When you talk about absolute value, we're talking about how far a number is away from zero. You may recall in earlier chapters, right? We simplified expressions that had absolute value, right? This is a distance from zero, right? How far something is away from zero is its absolute value. So if you look at the examples here, example A says we have the absolute value of -17, right? Remember those absolute value bars, those two long bars, that's the absolute value symbol. So if you take a look inside those bars, right, what is the absolute value of -17? Meaning how far away is -17 from zero? Well, the absolute value of -17 is going to be +17, right? Because our absolute value is always going to be positive. Example B says the absolute value of 9. Well, how far away is 9 from 0 on a number line? Well, it's exactly 9 units away. Right? Again, absolute value will always be positive. All right, let's look at letter C, right? Letter C looks a little different. It's the opposite or negative absolute value of -11. Well, again, we're going to focus on the inside, right? Inside my absolute value bars, I have a -11, and the distance from -11 to 0 is 11. However, this negative sign, right, I need to bring it over, right? I'm not done with it. So here, I would get an answer of -11, right? Because this is the opposite of the absolute value of -11, which is going to be -11, right? So this is going to say, right, whatever's on the outside is going to kind of stay on the outside unless we somehow get rid of it. All right, and now let's look at example D here, right? Example D is the absolute value of what, right? Absolute value of this question mark is equal to 4. Okay, so we have to think a little bit, right? What number or numbers can I put in this question mark inside this bar to get a +4? So let's see. Oh, I know. How about the number 4, right? If I put the absolute value of 4 in there, I will surely get 4. You think of another number besides 4 that I can put in here that will also give me a +4. Did you guess -4? Because if so, that's correct. So I can put a 4 in there, and that will give me a 4. I can put a -4 in that absolute value bar, and it'll also give me a 4. All right, which is going to lead me to my next statement here, or my next question. Based on the answer on number D, right, how many solutions do you think there can be for absolute value equations? That's right, we're going to have 2 solutions now. So we're going to work through these two example problems, numbers 1 and 2 together, and then we're going to go over the steps. And that will be kind of our day for today, okay? So directions say solve the following absolute value equations, right? And we can tell it's an absolute value equation because it has those bars around my variable or my x. All right, so number 1 says I have the absolute value of x is equal to 5. Okay, so that means I got to take a look at inside my absolute value bar. All right, I'm going to set that equal to 5. Right? Because I can know whatever's inside is going to equal to that outside. All right. But just like we said before, right, there's a possibility of having 2 solutions. All right. So now that means I need to write 2 equations. All right. So my first equation is going to be x is equal to 5. All right. And now, right, my second equation, right, because I can have a different value in there, right? Now I can say that x is equal to -5. Right, just like before in letter D here, right, I had 4 and -4. So same thing here. When I write my equations, I'm going to have one positive equation and I'm going to have one negative equation. And sometimes, right, that's all I'm going to need to do because, again, my goal of solving equations is to get x by itself. Well, look at this. I have x by itself, right? So I can say x is equal to 5, or I can say that x is equal to -5, right? So I have two solutions here. All right, let's try this again on number 2. And this will be like a next level type of problem. All right, number 2 says I have the absolute value of x plus 5 is equal to 11. All right, now this time inside my absolute value bar, I have a little more stuff, a little more terms in here to work with, right? So now same thing, right? I'm going to take what's inside of my absolute value bar, which is at x plus 5. I'm going to say that is equal to 11, right? Because that stuff inside is equal to a positive 11. But I can also say that that same stuff inside is equal to a negative 11, right? Because whatever that's on the inside, right, if it's a negative 11, the absolute value of negative 11 is positive 11. All right, and that's how I'm going to set up my two equations. But now this time, I can solve both of these equations, right? In example 1, there's nothing to solve. I had x by itself. But number 2, right, I got to do a little work now. All right, so this goes back to, okay, how do I get x by itself? All right, well, I'm going to put my line down the middle, and I only have one step to solve this one, right? I got to minus the 5 because I have to do the inverse operations, right? And what I do to one side, I need to do to the other side. So now when I do this, I can bring down my x. My plus 5 minus 5 cancels out, right? Because it's an inverse operation, right? I'm doing that on purpose so that I can get x all by itself. And now x will be equal to, well, now I have 11 minus 5. It's going to give me 6. So x equals 6 is going to be my first solution. And now I'm going to do these same exact steps to my second equation, right? But now my second equation is x plus 5 equals negative 11. Well, I'm going to put my line down the middle here. And again, I'm going to have one step to get that x by itself, and that's going to be the inverse operation, right? So x plus 5 equals negative 11. That means to get the x by itself, I need to subtract 5, right? And what I do to one side of the equal sign, I must do to the other. So now bring down my x, right? My plus 5 minus 5 cancels out because, again, I did that on purpose, right? My inverse operation will say to get that by itself equals, well, now I have a negative 11 minus 5 more, right? So now we're going to deal with negatives, right? So we're just going to use our calculator, right? Do negative 11 minus 5, and we should get negative 16. All right, if you don't get negative 16 when you do that in the calculator, try again, right? And make sure you're not doing negative 11 minus a negative 5, right? Because that's not what this says, right? This just says negative 11 minus 5 more gives me a negative 16. All right, again, if this kind of it's confusing, doesn't make 100% sense right now, that's okay, right? This is just day 1 of this. I just wanted to get you a little bit of background before we do some more problems tomorrow. All right, so now let's go over these steps that we just talked about. Right, so your first step, which we really didn't do today, but we'll get into this more so tomorrow. Step 1 says to isolate the absolute value expression by inverse operation. Right, again, my inverse operations, right, are adding with subtracting and multiplying and dividing, right? Adding undoes subtracting, just like subtracting undoes addition. And same thing with multiplication and division, right? Those are my inverse operations. All right. Now step 2 says, is the number on the other side of the equation negative? All right. So you have to ask yourself, once we isolate that absolute value expression, right, is the number on the other side of my equation negative? Right. If the answer is yes, then your equation has no solution. All right. And we're going to look at that more tomorrow. But most of the time, it's going to be the answer to that question is no, right? So if the answer is no, then we're going to go ahead to the next step, number 3 here. All right, step 3 says we want to set up two equations, right? Because we have two solutions, we need to set up two equations. All right, but when we set up these two equations, these are going to be without those absolute values. Right? We're going to drop those absolute value bars and make our two equations, right? One is going to be that expression equal to the number, right? And my other one is going to be the expression equal to the opposite of the number, right? So that's what we did up here, right? We said one equation was equal to 11, and the other equation was equal to negative 11. All right, and then our final step, as always, is to solve both equations. Right, and we're going to solve both equations by, again, doing that inverse operation and by isolating the variable. All right, and the last thing we want to do is to do this little practice problem on your own, right? This is a two-step equation, right? This is not an absolute value one, right? So we're only get a one solution here. But this is kind of a little bit of a review. All right, so go ahead and solve this equation and then put your answer into the video here. And after you do that, you'll be all set for today. And then we'll be back at this tomorrow.